right, so finding the inverse. Today you will be able to find the inverse of almost every function. So to begin with, you need to remember what it means to be an inverse. When do we use an inverse in our lives? Every day, Ms. Barris. So when you solve an equation, you have to use the inverse of things. So for example, in this guy right here, when you have this equation, in order to solve for x, we need to use the inverses to get rid of this -6 and the 2. So I need to use the additive inverse of -6, and I wind up getting 2x equals 24. Okay, these are the inverses of each other, so they cancel themselves out. Now this one here, the 2 is 2 times x here. That equals 24. So if 2 times x is 24, well then this thing divided by 2 will unwind it and get rid of it, and we'd be left with x is 12. So that's how we use inverses in our everyday lives, because I know you wonder. So, but what does inverse mean? So there's two kinds of inverses that we speak of most, that you've seen in your lives. And the additive inverse is when we take two numbers and we add them together, and their result is the identity. So 0 is the additive identity. Additive identity. And that just means an identity is something we can add to anything. So if I add 0 to x, the identity stays. So x stays x. It doesn't change to 2x or 3x or anything else. So 0 is the identity. So inverse means, say I take 5. What can I add to 5 to get it to be the identity, or 0? Well, hopefully it's pretty obvious to you. It's -5. So these two are inverses of each other. So 5 and -5 are additive inverses. Additive inverses of that was very neat handwriting, you're welcome, of each other. That's an inverse. Multiplicative inverse is same idea, but the identity in multiplication is different. The identity in multiplication is 1. So if I multiply something times 1, I get itself. It keeps its identity. So the multiplicative inverses of each other are two things multiplied together equal 1. So let's start with 2. So what is the multiplicative inverse of 2, or what is the inverse of 2? Well, it's simply a half. And it is division, it's multiplying by the reciprocal, but it's the same idea as if I just divided it by 2. It's the same idea. Multiplying by its reciprocal is the same as dividing by it. Okay, so now we have to talk about the inverse. Sorry, got all these different functions lately on this program. All these different, whatever. We have to, welcome back. The inverse of functions is what we have to talk about. So what is a function? How do I deal with that? So what we do, the inverse of functions, now hopefully you know what a function is. It's a thing that passes the vertical line test and all those wonderful things. It's a series of points, when you put them together, form a curve, a graph of some sort. So functions are when you reflect that function through the line y equals x. That's a function. That is the inverse of a function. Reflecting that graph through the line y equals x. The basic idea is switch x and y. You should remember this from last year, from whatever you did, geometry or whatever algebra you were in. When you reflect something through the line y equals x, you switch x and y. And that's it. So that's what we're going to be doing. We're going to be switching our x and our y and dealing with what happens. So notation. So hopefully you realize and remember that f of x is your regular function notation. So this is function notation, and it said f of x. That's how you say it. It's f of x. It looks like f x, but it's f of x. This right here is the notation for the inverse of f of x. This is the inverse. It looks like to the -1 power, but it isn't. It actually represents the inverse. So you kind of say it backwards. Of f of x. Just like the $sign and whatever, the question marks. You kind of say things backwards when you do that. So the inverse of f of x, this is the notation. So sometimes we don't even tell you, use the word inverse in anything. And you need to know that this little symbol right here, with the little -1 sign, means I have to take this function and find the inverse. In order to do this, you need to remember how to solve equations and lots of different kinds of equations. So just recall, and we're going to do this quickly, the inverse of addition. So if we're in an equation and we want to find the inverse of addition, it's simply subtraction. Subtraction, the inverse is addition. Multiplication is division. Division is multiplication. So these are the inverses of all these. The inverse of squaring is square rooting. Okay, and I'm just going to show you an example of this. So if I do x squared equals 9, like if x has a square on it, again, x has to have the square on it, or the variable has to have the square on it to actually do this problem, to have to do it with the square root. So in order to get rid of the square, we square root. And when we do that, we get x equals plus or minus 3. Now that's shorthand for saying x equals 3 and x equals -3. I know in the past you have eliminated that -3, but not in this class. Sometimes we do, but not now. Only when it checks out that, only when we check it and it doesn't work. So this isn't length or anything like that, like geometry would be. So we have to keep our -3. So we have to keep both of these guys for our answer. And then if we have a square root, we square to get rid of it. Of course, we do more than that, but this is where we're starting. So the square root of x, say, is equal to 2. In order to get rid of the square root, I square both sides, and these two kind of cancel each other out, and we're left with x equals 4. All right, we're going to do some examples, but first I'd like you to look at the bottom of the page, and these are the basic steps to finding the inverse of a function. The first thing you want to do is get rid of the f of x just for notation's sake, just make it easy on us. And you'll see why in a second. Then we switch our x and our y, and this is the major step here that makes the inverse. The hardest one is solving for y, because you actually have to do some math there. These two are pretty straightforward, and you should be able to do that regardless. And then finally, once we've solved for y, we put that inverse notation in for ourselves and the greater. So for an example like this, first thing we're going to do is make that a y. F of x and y are the same thing. We just use f of x and g of x and all those different letters because it helps us identify different functions easier. If we just used y for everything, they'd all be the same function. So y equals 2x minus 3. Now we switch the x and the y. So wherever x is, y is, they change. So y now is x, and x is now y. Okay, after that, we have to get y by itself. So this is y, so we have to get it by itself. We have to get rid of that -3 and the 2. So it's just straightforward solving an equation. So we add 3. When I add 3 to x, hopefully you remember that we can't. They are not like terms. So they just stay there, and then we divide by 2. That's the inverse. X plus 3 over 2 is the inverse. So we rewrite this with the function notation in place of y. So wherever that y is, that's left. We put the function notation. I just like to write it the other way around, and I get x plus 3 over 2. Funny enough, that's not the only way you'll see it. Okay, you could take that 2 and divide it into both of these. So I could technically get also x over 2 plus 3 over 2, and with bringing that down also. And we could get also, this is 1/2 x plus 3 over 2. So when we do something like this, notice that this 2, that's almost like there's an imaginary 1 there, and the x, even if it's on the side, it's the same as it being on the top. Side and top are the same thing. All right, that's how you do the inverse. This one's pretty funky. You have to remember some things from the past, but I think you guys can handle it. So replace the y. These first 2 steps, everyone should be able to do without any pain. Anywhere you see a y, you put an x. Anywhere you see an x, you put a y. And now we have to solve. So how do we solve this? There are 2 y's, Ms. Barris. I'm having a heart attack. All right, it's pretty straightforward. Cross multiply. So you get xy equals y minus 3. Now, this one is a little tricky. I'm not going to pretend otherwise. But it's pretty straightforward. You subtract your y. What you want to do is you want to group things that are the same. So these 2 y's, we want them to be together. If any of the terms have a y, I get it on one side, and everything that doesn't have a y, it goes on the other. So this -3 term doesn't have a y, but these 2 terms do. So we have to put those together. So now that I put that together, I get xy minus y. Remember that I can't combine those 2 because those are not like terms. I'm going to write them up here so I don't have to change my screen. All right. Now, how do I get, what do I do now? Well, the trick is, pretty straightforward trick, is we have to factor out a y. I know it's been a while since you've done factoring, but it's just GCF. If you look at both of these terms, you have a GCF in both of them. You have a y in this and a y in this. So all I have to do is factor out that y. You divide by y in both of these, and you're left with x minus 1 equals -3. So now this is y times x minus 1. So I simply divide by x minus 1. This one is a little tricky, and I'm not pretending that it isn't, but I have full confidence that each one of you can practice it and get it down. So the inverse of this one is f inverse of x is equal to -3 over x minus 1. Okay? So next one. So let's do these quick. Get you out of here. Change f of x to y. Switch x and y. So everywhere there's a y, you put an x. Everywhere there's an x, you put a y. Add. So we want to get y by itself. Now we have a squared, so the inverse of squaring is square rooting. So those go away, and we're just left y. And remember, it's y plus or minus the square root of x plus 3. So the inverse here is plus or minus the square root of x plus 3. All right, and then finally the last one. This one is using square roots, so hopefully you remember we're going to be squaring stuff. So we switch our x and our y. And we solve for y. So right now that 4x minus 7 is stuck underneath this square root. So what I have to do is I need to square both sides to get it unstuck. I can't remove anything from underneath that square root sign without squaring it. I have to get rid of that square root. And now it's straightforward. Now I just solve. But now it's x squared instead of just x. Divide both sides by 4. And f inverse of x sorry, is equal to x squared plus 7 over 4. Now remember all the different ways you can rewrite that guy also. All right, have a good day.